There's something strangely magnetic about this image. You're looking at Proxima Centauri, a star that has fascinated astronomers for more than 100 years. It's impossibly close by cosmic standards, yet still would take entire generations to reach. It's hidden from the naked eye, but remains the nearest star to our solar system. At one point, it was the faintest star ever discovered, and paradoxically, one of the most active. Just when it seemed like we'd learned all we could, scientists discovered a planet in orbit, one that seemed strikingly Earth-like. Suddenly, the idea of traveling to another star system didn't feel like science fiction anymore. It sparked real conversations, not just among scientists, but among tech visionaries like Zuckerberg, Musk, even Stephen Hawking. It's almost as if this little star is taunting us, offering a glimpse of something we can almost reach, but not quite. And if you're anything like me, you want to know everything about it. So let's begin a journey through the Alpha Centauri system, starting with the binary stars Alpha Centauri A and B, then diving into what makes Proxima Centauri so unusual, the planets we found around it, a controversial discovery, and the kind of mission that might finally take us there. Leaving Earth, it would take just over 4 light years to reach the nearest known stars beyond our solar system. I say stars because technically they form a triple star system. Together, they're known as Alpha Centauri, made up of Rigil Kentaurus, also called Alpha Centauri A, Ptolemy, also known as Alpha Centauri B, and Proxima Centauri, the faint third member. Rigil Kentaurus and Ptolemy orbit each other as a binary pair, known as Alpha Centauri AB. They lie about 4.37 light-years away, and both are sun-like stars, circling a shared center of gravity every 79.76 years. If you live south of the 40th parallel, you could spot them in the night sky, although to the eye, they appear as a single star. It's the third brightest point in the sky, behind only Sirius and Canopus. The Alpha Centauri binary was first identified back in 1689, but it took more than 200 years before the third star revealed itself. That moment came in 1915, thanks to a Scottish astronomer named Robert Innes. At the time, Innes was working as director of the Union Observatory in Johannesburg, South Africa. While comparing photographic plates with a blink comparator, he noticed something strange. A faint star had moved across the sky in just 5 years, and interestingly, its motion matched that of the Alpha Centauri binary he was studying. Could this new star be part of the same system? After further investigation, Innes concluded that the new star wasn't just a chance background object. It was actually closer to the Sun than its twin siblings. His finding was quickly confirmed by other astronomers, and so Proxima Centauri took its place in history as both the closest known star to Earth and, paradoxically, the dimmest. But the surprises didn't stop there. In 1951, American astronomer Harlow Shapley discovered that Proxima Centauri is a flare star, a kind of star known for unpredictable outbursts of energy. Even more surprising, it turned out to be the most active flare star known at the time. Over the last 70 years, Proxima Centauri has remained a source of fascination for astronomers. And with the discovery of an Earth-like exoplanet in its orbit, that interest is only growing. But let's not get ahead of ourselves. Before placing such big hopes on this little star, let's understand what it actually is. Proxima Centauri lies 4.24 light-years away, slightly closer than Alpha Centauri AB. It's a main-sequence red dwarf, with just 12.2% of the Sun's mass, and a diameter around 15% of the Sun's. Despite its small size, it's incredibly dense, about 40 times more so than our Sun. Because of its low mass, the interior of Proxima Centauri is fully convective. That means hot plasma constantly circulates from the core to the surface. This movement generates strong magnetic fields, and those fields sometimes release their energy all at once in the form of violent stellar flares. Because of this magnetic activity, Proxima Centauri can undergo dramatic shifts in brightness. One flare in particular, observed on May 6, 2019, became the brightest ever recorded from this star. If only for a moment. These flares unleash radiation across the electromagnetic spectrum, including powerful bursts of X-rays. To give you some context, Proxima Centauri's baseline X-ray output is already comparable to our Sun, despite being much smaller and cooler. And during a flare, that level can spike by as much as 100 times. In fact, not only are the flares stronger than the Sun's, they also happen more often. It's estimated that around 88% of Proxima's surface is active at any given moment, far more than our Sun, even at the peak of its solar cycle. Still, before you picture Proxima as a raging inferno, remember, we're comparing two very different kinds of stars. Our Sun is not a red dwarf, and when viewed alongside its peers, Proxima Centauri is actually considered a relatively calm red dwarf. The difference lies in how these stars burn through their fuel. While the Sun will consume just 10% of its hydrogen before aging out, Proxima Centauri is expected to burn through nearly all of it. It will remain on the main sequence for an astonishing 4 trillion years. By that time, Earth, the Sun, and everything we know will be long gone. Alpha Centauri. AB is about 0.13 light years, or 2 trillion kilometers, from Proxima Centauri. You might wonder, if it's so far from its siblings, why is Proxima even considered part of the same system? The answer lies in gravity. Despite the distance, data shows that Proxima is gravitationally bound to the Alpha Centauri AB pair, following a long, looping orbit that takes roughly 550,000 years to complete. How it ended up in this arrangement is still debated. One possibility is that Proxima formed alongside the other two stars, meaning all three share the same elemental makeup. The second possibility is more dramatic, that Proxima was a rogue star, captured later by the binary's gravity. If that's the case, its orbit would have originally been chaotic and highly eccentric, eventually stabilized by the slow tug of the galaxy itself and interactions with nearby stars. Whichever path brought Proxima into this system, its time there isn't forever. Based on current models, in about 3.5 billion years, it will break away. As Alpha Centauri AB evolves and loses mass, its grip on Proxima will weaken until the connection is lost. Even the binary itself won't last. In around 12 billion years, Alpha Centauri A and B are expected to part ways as they transform into white dwarfs, drifting apart on their own paths through the galaxy. As our closest neighbors, we know a fair amount about Alpha Centauri AB, but we'll save a deeper dive into those stars for another time. Right now, all eyes are on Proxima Centauri. The search for planets around Proxima Centauri began in the mid-2000s. For years, nothing conclusive emerged, but astronomers didn't give up. This was, after all, the closest star to us, and as a red dwarf, Proxima was statistically promising. Between 20 to 40% of red dwarfs are thought to host planets within their habitable zones. That possibility kept astronomers watching and waiting. Eventually, patience paid off. Observations from the European Southern Observatory in Chile revealed strange anomalies in Proxima's light. These changes couldn't be explained by flares or other solar activity. Something else was tugging at the star. And in January 2016, the Pale Red Dot campaign was launched. It was a global effort, combining data from telescopes and experts around the world to see if a planet could be confirmed. That August, the discovery was made official: Proxima Centauri b, an exoplanet at least 1.07 times the mass of Earth. It orbits 20 times closer to its star than Earth does to the Sun, completing a full orbit every 11.2 Earth days. And remarkably, it sits inside the star's habitable zone, where temperatures could, in theory, allow liquid water to exist. But habitability is far more complex than that. Even within that zone, Proxima b faces brutal conditions. Its parent star unleashes far more ultraviolet and X-ray radiation than our Sun, anywhere from 10 to 60 times more. To survive there, we'd need sunscreen with an SPF of 3,000. But more importantly, such radiation could slowly strip away the planet's atmosphere, assuming it ever had one. And without an atmosphere, water can't remain stable on the surface, nor can life, as we know it. The question of whether Proxima b still holds onto an atmosphere remains unanswered. Unfortunately, we don't know much else about this planet. We know its distance from the star, and we know its orbital period. But beyond that, things get murky. It's unlikely to have any moons. Their orbits would be too unstable in the long term. And it's believed the planet is tidally locked, meaning one side always faces its star, while the other remains in darkness. That doesn't bode well for surface conditions. It's also probable that Proxima b formed under very different conditions than Earth. If it began its life where it currently orbits, its formation would have been fast, chaotic, and lacking in water. But not everyone agrees. Some scientists believe there wasn't enough material in the protoplanetary disk that close to the star for a planet to form. Instead, they think Proxima b formed farther out and slowly drifted inward over time. As for what the planet actually looks like, we just don't know. It could be covered in ice, or it might have vast oceans, although that's unlikely if the planet is tidally locked. Some suggest it could be a dry, barren world, or perhaps one with a subsurface ocean like Europa. But until we see it for ourselves, all of this remains speculation, and for that, we'll need a flyby, something a few visionaries are already working toward. 6 years after the announcement of Proxima b, another revelation made headlines: the detection of a second planet, Proxima Centauri d. The first signs appeared in 2020 when researchers noticed a faint 5.15-day signal in the radial velocity data. At the time, they were studying the mass of Proxima b, but the new signal hinted at something else. Further observations and analysis followed, and in February 2022, the discovery of Proxima d was confirmed. This planet is what we call a sub-Earth, with only about 25% of Earth's mass. It orbits extremely close to its star, just 4.3 million kilometers away, completing a full orbit every 5.1 days. That proximity pushes its equilibrium temperature up to 87 degrees Celsius, far too hot to support life as we know it. And like Proxima b, it's probably tidally locked, with one blistering side always facing its star. Radiation levels at that distance are extreme, so even though Proxima d is fascinating, it's not considered a likely home for life. But it's important for another reason: a breakthrough in detection. Proxima d is the lightest planet ever discovered using the radial velocity method. This technique relies on detecting a star's slight wobble caused by the gravitational pull of an orbiting planet. The more massive the planet, the more obvious the wobble. In this case, the wobble was nearly undetectable. And yet, the team caught it and confirmed it, with enough certainty to call it a planet. That's a technological achievement worth celebrating. Detecting something so subtle around a star so active proves just how far our instruments and our persistence have come. Of course, not every discovery comes without questions. In the case of Proxima Centauri c, uncertainty hangs over everything. It was first detected in 2019 using the same radial velocity method that found Proxima d. A year later, in 2020, that detection was supported by data from the Hubble Space Telescope, using astrometry to track the star's movement with extraordinary precision. At first, it looked like solid confirmation, but in 2022, a separate team of researchers challenged the original findings. They suggested that the radial velocity anomalies might not be from a planet at all, but instead the result of tiny, unaccounted-for systematic errors in the data extraction process. In other words, a miscalibration. That's where the real problem lies. Unlike Proxima D, which orbits very close to its star, Proxima C appears to be far more distant, with an orbital period of about 1,928 days. That makes the signal much harder to verify. There is no similar example of a wobble detection of a planet with such a low amplitude at such a long period, said astronomer Paul Robertson in an interview. That doesn't necessarily mean it's wrong, but it will take more data to be sure. If Proxima C really exists, it would be a major addition to the system. But if it doesn't, we're left wondering how the Hubble data managed to align so closely with the original detection. Either way, this is the nature of science, especially when you're studying faint stars, far across the void. With Proxima B now confirmed, and the star itself so close by, it's no surprise that Proxima Centauri has become a prime candidate for a future flyby. But there's one enormous challenge. Even though it's our nearest neighbor, getting there would take thousands of years using today's propulsion technologies. To make the journey feasible within a human lifetime, we'd need something radically different, something like solar sails or nuclear propulsion. That's where Project Breakthrough Starshot comes in, a visionary initiative proposed by physicist and investor Yuri Milner, the late Stephen Hawking, and Mark Zuckerberg. Their goal is astonishingly ambitious: to reach the Alpha Centauri system by the middle of this century. The plan? Send a fleet of microprobes, each weighing just a few grams, flying at 15 to 20% the speed of light. If successful, they could launch by 2036, arrive in 20 years, and beam data back to Earth just 4 years later. After the initial flyby of the system, these probes could continue on, targeting planets like Proxima B to gather atmospheric data, just as Voyager once did for the outer solar system. But these wouldn't be ordinary spacecraft. The heart of the mission is something called the Star Chip, a tiny microelectronic wafer carrying cameras, navigation, power systems, photon thrusters, and communications gear, all on a probe no larger than a postage stamp. The idea sounds like science fiction, but it's grounded in real science and Moore's law. As our electronics grow smaller and faster, this kind of probe becomes increasingly viable. Still, the challenges are immense. To push these tiny crafts to such high speeds, the team proposes a 100 gigawatt Earth-based laser array, the equivalent output of 100 nuclear power plants, aimed precisely at probes just centimeters wide. It's an elegant idea, but it comes with serious engineering hurdles. Every component of these probes would need to survive the most extreme conditions imaginable. The acceleration would be immense. The cold, the vacuum, the interstellar dust. All of it could destroy such a tiny craft. That's why some suggest the name Breakthrough Longshot might be more fitting than Starshot. But if the history of spaceflight teaches us anything, it's that the most improbable missions often become our proudest triumphs. We've sent probes past every planet in our solar system. We've seen alien moons, danced through asteroid belts, even landed on comets. And all of it began with impossibly bold ideas. Proxima Centauri might just be the next chapter, a mission that could redefine our understanding of planets beyond our sun. If these microprobes make it, if we one day see an image of Proxima B's surface, or detect the chemistry of its skies, it would be a moment as transformative as Voyager, maybe more. And yet, we have to be patient. Because even with the most optimistic timeline, launch in 2036, arrival in 2056, it would still be 2060 before the first data reaches Earth. Many of us may not be around to see that day, but that's what makes it beautiful. Like planting a tree whose shade we'll never sit under, missions like this are acts of hope, a gift to the next generation of explorers. Proxima Centauri is not just a star, it's a reminder of how much we still don't know, how much we're still willing to reach for. It's close enough to tempt us, but distant enough to challenge everything we've built so far. And if we rise to that challenge, it might just earn its place among the greatest stories ever told in space exploration.